1962 Heathkit Mohican GC-1A shortwave receiver restore. Today on Radio Boat Anchor, I'm going to restore this vintage 1962 Heathkit Mohican GC-1A shortwave receiver that I recently purchased on eBay. Years ago, I restored my father's Mohican shortwave receiver. You could read about it in my Radio Boat Anchor blog. I will include a link in the description. The restoration of my father's Mohican shortwave receiver was so gratifying that I decided to restore another one. An assembled Heathkit Mohican in good shape could fetch over $200. I didn't want to spend that much. In addition, I wanted the challenge of a detailed restoration. I found this Heathkit Mohican receiver in a for parts or not working condition on eBay. I offered the seller $84.99 plus tax, and the seller accepted. Can you tell what state this receiver's from? The Heathkit Mohican assembly manual is essential for servicing and restoring this vintage shortwave receiver. I will include a link in the description on where you can download it in PDF format. The Heathkit Mohican receiver requires 12 volts DC and draws a maximum of 35 milliamps. Power can be provided by either 8D batteries installed in the battery box or the optional XP-2 AC power supply. Polarity alert! Due to the extensive use of PNP transistors in the Mohican receiver, Heathkit designers chose to make the chassis positive ground. This means if you choose to power the unit with the external power supply, the metal chassis should be at 12 volts DC positive potential. A good place to connect to 12 volts DC negative potential is to the muting terminals at the back of the chassis, which should be jumpered during normal operation. The muting terminals where you connect negative 12 volts DC are circled in the picture. XP-2 AC power supply recap. Recap is a replacement of old electrolytic capacitors in vintage equipment. Electrolytic capacitors have a finite lifetime. As they age, the electrolyte dries up, causing their capacitance to fall in value. This is most evident in power supply filter capacitors. You will hear AC hum from the speaker of the equipment as the filter capacitor's capacitance drops in value. The XP-2 AC power supply is installed in the back of the Mohican receiver. It is held in place by two snap fittings. Use the pull ring and pull it straight back and then disconnect the internal power supply cable. Remove the rectangular aluminum cover from the XP-2 AC power supply. It is held in place with 4 nuts. The AC power supply was completely disassembled for cleaning. The aluminum cover and mounting plate were cleaned using my go-to cleaner, Windex. Magic Eraser was used to remove years of grime on the AC power cord and the plate. This section was sped up for brevity. Each part was thoroughly rinsed in order to remove bleach residue. Armor All was used to restore the sheen to the vinyl on the AC power cord, and to restore the luster to the green paint on the mounting plate. All screws were removed from the XP-2 AC power supply. The screw heads were sanded to remove any surface rust using 800 grit sandpaper. I used a drill to speed up the sanding process. Once the screw heads were sanded then cleaned, they were sprayed with clear Rust-Oleum paint. The power supply was then reassembled using the original parts. Look how nice the screw heads look. I decided to install a 7812 voltage regulator to keep the output voltage at a constant 12 volts. 2.1 microfarad capacitors were installed between the input and ground and output and ground of the 7812. These capacitors will prevent the 7812 from oscillating during high loads. The 2 electrolytic capacitors were placed in the XP-2 AC power supply. The replacements were much smaller than the originals. The builder of this power supply put a jumper in place where the 8th amp 250 volt fuse was supposed to be installed. The jumper was removed and the 8th amp 250 volt fuse was installed, along with the power cord. Electrical tape was installed onto one of the electrolytic capacitors, then the 7812 voltage regulator was affixed to the capacitor using a tie strap. The metal tab of the 7812 cannot be bolted to the mounting plate, otherwise it will cause an electrical short. Here is the schematic containing my regulator modifications to the XP-2 power supply. The XP-2 power supply was load tested prior to final assembly. A 1/4 watt 470 ohm resistor was used as the load. My Radio Shack Micronta volt-ohm meter was used to measure the output voltage, while my Kaiweets volt-ohm meter was used to measure the current draw. All was in order. The rectangular aluminum cover was then reinstalled and held in place with 4 nuts. My XP-2 power supply was ready for installation into my Heathkit Mohican receiver. Disassembly. The chassis was removed from the cabinet in order to access the electronics. Typically you would remove the telescopic antenna, but it was missing from this receiver. The power supply was removed in a previous section. 4 screws typically hold the chassis in place inside the cabinet. Only 3 disparate screws were holding the chassis in place for this rig. Typically the speaker was fastened to the inside of the cabinet. It was missing from my Heathkit Mohican receiver and was typically connected to the end of this cable. Faceplate repair. The front panel of my newly acquired rig was for some reason bent inward. I used vice grips with the jaws covered in electrical tape to prevent scratching to bend the front panel as close to its original position. A piece of 2x4 lumber was used to determine how close the front panel was to its original position. I also used a small rubber mallet to assist in the bending process. Chassis cleaning and lubrication. The chassis was thoroughly cleaned using my go-to cleaner, Windex. I used Q-tips moistened with Windex to get into hard-to-reach places on the printed circuit board. A previous owner affixed a Texas sticker to the dial plate. I used a razor blade to carefully remove it, then used Windex to remove any residue. All chrome knobs were removed. They have 1 or more Allen set screws to affix them to the shafts. Q-tips moistened with Windex were used to clean front panel crevices. Labelle 107 plastic-friendly model train oil was then used to lubricate the shafts of all front panel controls. The chrome knobs were polished using Meguiar's Motorcycle All-Metal Polish. S-meter repair. The S-meter was pushed back into the chassis. I desoldered the meter from its wiring in order to make it easier to service. The clear plastic dial plate was shattered. Looks like the meter was manufactured by Electromechanical Instrument Company of Perkasie, Pennsylvania. I used a AA battery to test meter movement. Momentary touching the negative lead to the negative meter movement connection. The meter's indicator sprung to life, indicating it was in working order. A new dial plate window was created from an old clear plastic battery package. Jeweler's GS Clear Cement was used to affix the new window to the meter. The repaired meter was mounted back into its mounting hole in the front panel and held in place with a clip. In addition, the wires were soldered back to the meter's terminals. Here is the repaired meter face. Electrolytic capacitor recap. As mentioned, recap is a replacement of old electrolytic capacitors in vintage equipment. Electrolytic capacitors have a finite lifetime. As they age, the electrolyte dries up, causing their capacitance to fall in value. This section describes the replacement of electrolytic capacitors in the Mohican receiver. C56, C57, and C58 are all housed in the same case. Each has a value of 100 microfarad with the 15-volt max rating. Triple capacitors are hard to find these days. I replaced C56, C57, and C58 with 3 discrete electrolytic capacitors of the same rating. The next capacitor to be replaced was C59. It had a value of 50 microfarad and a 15-volt max rating. I replaced C59 with a 47 microfarad electrolytic capacitor with a 15-volt max rating. Most capacitors have a capacitance tolerance of 20%, so this value is close enough. C55 is an electrolytic capacitor rated 150 microfarad at 15-volt max voltage rating. I replaced C55 with a 100 microfarad and a 47 microfarad electrolytic capacitor in parallel, which combined for a total of 147 microfarad capacitance. This is close enough to the original value. C27 was a 10 microfarad capacitor with a 10-volt max rating. C27 was replaced with a new electrolytic capacitor similar in spec to the original one. C54 is located on the underside of the printed circuit board and is connected to a terminal strip. It has a value of 50 microfarad with a 15-volt max rating. I replaced C54 with a 47 microfarad electrolytic capacitor with the same voltage rating. During electrolytic capacitor replacement, I came across this paper capacitor that also becomes unreliable with age. It was replaced with a new Mylar equivalent. Band switch coupler replacement. The original coupler between the front knob shaft and the multi-deck band switch shaft had broken. I originally tried a 1/4 inch to 1/4 inch bore rigid coupler, but found that it was very difficult to turn the band switch due to a slight alignment problem. Instead, I used a 6.35mm to 6.35mm shaft flexible coupler used in 3D printers, which alleviated the binding problem. Dial light repair. There are 2 light bulbs, one on each side of the dial plate, in order to illuminate it. I decided to replace both number 49 bulbs with new. The left dial light socket was unscrewed from its mount, and a new bulb was installed. The left bulb socket was then reinstalled with a single screw. The front panel was still slightly out of alignment. I had to cut a groove into the dial light standoff in order to prevent the dial cord from chafing on it. The bulb in the right bulb socket was replaced as well. It was also held in place with a single screw. Cleaning and lubrication. I used the Oxid D5 contact cleaner to clean the contacts and wipers of the front panel potentiometers. This was an opportune time to test the power switch contacts on the volume control, using the continuity setting on my volt-ohm meter. The front panel slide switches were cleaned with the Oxid D5 contact cleaner as well. The band switch shaft was lubricated with Labelle 107 plastic-friendly oil intended for model trains. The detent mechanism was lubricated with Labelle 106 PTFE grease. The band switch contacts on each deck were cleaned with the Oxid D5 contact cleaner. The antenna tuning shaft was also lubricated with Labelle 107 oil. And then the band spread shaft here and here. Tuning capacitor replacement. The main tuning air capacitor was missing a section of plates and needed to be replaced. And the dry pulley had separated from the coupler. In order to remove the main tuning air capacitor, I had to desolder these 3 wires. The main tuning air capacitor was held to the chassis with 3 screws. The heads of the screws holding the main tuning air capacitor in place were accessible from the bottom of the chassis. The main tuning air capacitor removed from the chassis. I did a buy it now purchase on eBay for a similar replacement Heathkit tuning air capacitor, as I couldn't find the exact same one. Its shaft was shorter, and on the opposite side as the original. Before installation, I decided to check continuity between each set of movable and fixed plates. There should be no continuity as the movable plates move through the fixed ones. I moved the long shaft over to the replacement tuning air capacitor. With the shaft on the opposite side, I discovered that I would need to mount the replacement upside down. I fabricated a mount for the replacement tuning air capacitor from 2 Stanley L brackets. Then performed the dry fitting of the bracket on the chassis, with the replacement tuning air capacitor installed. I had to extend the connecting wires now that the replacement tuning air capacitor was inverted. The main tuning dry pulley was badly bent and the coupler had separated from it. The dry pulley and coupler were free and clear once the dial cord was removed. I had to hammer out the dry pulley with a rubber mallet on a piece of 2x4 in order to straighten it. The coupler had 4 tabs to keep it fastened to the dry pulley. I attached the coupler to a drill bit, then used my grinder to remove the 4 tabs. Then soldered the coupler to the dry pulley. The shaft was removed from the replacement tuning air capacitor in order to mount the tuning dry pulley, and the tuning cord was reattached to it. Through testing, I had determined that the dial cord needed to be attached to the dry pulley at the bottom instead of the top in order to change its direction and to be compatible with a replacement tuning air capacitor. I had to fabricate a bracket using 2 solder lugs and found a pulley from my junk box, in order to keep the reverse wound dial cord from jumping off of the dry pulley. I spray painted my fabricated bracket and pulley matte black so that it matched the surrounding chassis. The main tuning shaft was bent, causing it to bind when turned. Loosening the bushing allowed the shaft to spin freely. I lubricated the band spread dial pulley axles with my Labelle 107 oil. Band spread repair. The band spread mechanism consists of the dry pulley connected to a gear-driven air capacitor. The dial cord had worked its way loose from the dry pulley. 2 set screws were loosened in preparation for the band spread mechanism adjustment and restringing the dial cord. This allowed me to remove the band spread dry pulley in order to straighten it. Labelle 107 plastic-friendly model train oil was used to lubricate the band spread dry pulley shaft here and here. Labelle PTFE 106 grease was used to lubricate the band spread air capacitor's bearings. I consulted the Heathkit GC-1A manual in order to properly adjust the band spread stop. The coupler had come loose from the band spread dry pulley. I soldered the coupler in place. Once the band spread dry pulley was reinstalled onto the shaft, I used the Heathkit GC-1 manual pictorial to restring the dial cord. Here were the results. The band spread shaft was bent, causing it to bind when turned. Loosening the bushing allowed the shaft to spin freely. I was having a problem where the band spread dial cord kept slipping off these pulleys. Raising the secondary pulley resolved this issue. The band spread dial indicator was getting stuck, close to mid-range. I cut a 1/2 by 1/8 inch adhesive foot in half. Then carefully pushed the adhesive foot halfway down from the top, between the dial window and backplate. This allowed the band spread dial indicator to move freely across the entire range. Finally, I lubricated the band spread dial pulley axles with my Labelle 107 oil. Antenna mount modification. My Mohican receiver was missing its original telescopic antenna, which gets mounted in this hole on the chassis once the enclosure is installed. The original antenna screwed onto this 632 by 1/2 inch screw. I purchased a large replacement telescopic antenna from Amazon. It had a large metric thread and nut. 2 connections were desoldered from the antenna solder lug. Then 4 screws were removed in order to free the phenolic antenna base from the chassis. I needed to somehow mount the antenna nut to the phenolic antenna base. A washer was soldered to one side of the antenna nut. The original 6/32 by 1/2 screw was threaded through the washer soldered to the nut and fastened to the phenolic antenna base. The original solder lug was fastened to the other side. Here was the result. The phenolic antenna base was reattached to the chassis with 4 screws. Then I soldered the 2 connections to the solder lug. The antenna was screwed into the chassis in order to test fitment. It was then removed until the metal cabinet was installed. Chassis screw refinishing. Many of the chassis screw heads were rusted. Starting with a printed circuit board, I removed the chassis screws in preparation for refinishing their heads. Here are the printed circuit board chassis screws ready to be refinished. Each screw head was sanded with 800 grit sandpaper, cleaned with degreaser, then sprayed with a clear finish. All visible chassis screws were given the same treatment. Visible chassis nuts were removed and turned upside down in order to show the non-rusted sides. I had to use specialized tools such as forceps and tweezers in order to place some of the lock nuts and nuts in place under the chassis. Knob installation. The band switch knob was already in place due to the shaft coupler replacement. I used a 1/4 inch length of fuel line split lengthwise as a spacer on both the main tuning and band spread shafts, so that the knobs did not rub against the front panel. Each knob is affixed to its shaft by 1 or more Allen screws. Each knob has an indented red pointer in order to show orientation. I used denatured alcohol to clean them. I then applied Tester's dark red enamel hobby paint to each indented red pointer in order to restore their color. Here was the end result. Initial power up and alignment. I used a Benz power supply to provide the 12 volts required to power up this receiver. The Mohican receiver is positive ground, so the positive connection was connected to the chassis, while the negative was connected to the jumper muting terminals. Success! My Mohican receiver started to pick up AM broadcast band stations upon power-up. Based on my preliminary testing, the previous owner did a fairly good job of tweaking the IF transformers and each band alignment. I decided against trying to realign this receiver, as the replacing tuning capacitor consisted of 3 variable air capacitors with a range of 15 picofarad to 480 picofarad, while the original consisted of 3 variable air capacitors with a range of 9 picofarad to 290 picofarad. Based on the difference in capacity, I don't think I could have performed a proper alignment. In addition, I didn't want to fiddle with frail 64-old trimmers and coil slugs located on the top of the chassis. The alignment procedure for the Mohican receiver starts on page 61 of the Heathkit GC-1A manual. S-meter troubleshooting. With the AVC or automatic volume control in the on position, the S-meter should jump when the broadcast signal is tuned in. Instead, the S-meter jumps from 10 when the AVC is switched on to 0 when switched off. During troubleshooting, I discovered a missing ceramic capacitor on the printed circuit board. I installed a 0.07 microfarad film capacitor, hoping it would fix my S-meter problem. It did not, but it did slightly increase the sensitivity of my Mohican receiver. Cabinet restoration. The original speaker was missing, so I replaced it with a new one of the same impedance, but unfortunately it had different dimensions. I had to use a large fender washer to hold it in place. These spring clips hold a XP-2 AC power supply in place. Vice clips were used to bend them back into position. I did a test fit of the replacement telescopic antenna to make sure it fit into the original grommet. The metal cabinet of my Mohican receiver needed a thorough cleaning. First, I removed the aluminum carry handle and the remaining broken feet. Then I cleaned it both inside and out with my go-to cleaner, Windex. Armor All was used to bring back the luster of the metal cabinet's paint. Final assembly. I decided to make one modification before final assembly. I removed the 68 ohm resistor that dimmed the dial lamps under AC power, and connected the 2 wires together so that they glowed at maximum intensity. I originally installed 3D printed Heathkit style feet purchased from eBay on the metal cabinet, but one delaminated during assembly. Instead, I installed standard electronic rubber feet. The carry handle was then installed. Then the coax audio cable was then soldered to the speaker terminals. One last check was then done to make sure none of the wiring was coming in contact with any moving parts. The speaker had to be installed in the metal cabinet prior to installing the chassis. As mentioned, the fender washer had to be used to secure the replacement speaker in place. It was then time to slide the chassis into the metal cabinet. Once the chassis was slid all the way into the metal cabinet, it was secured in place with 4 Phillips sheet metal screws. The XP-2 AC power supply was connected to the chassis. Then it was pushed into the metal cabinet and secured in place with 2 screws. Finally, the large antenna was installed by pushing it into this large grommet and threading it in place to the chassis. Oh, here's a picture of all the capacitors replaced during this project. Conclusion. Here's my newly restored Mohican receiver in action. It is proudly displayed on my computer desk. As mentioned, this was my second Mohican receiver I have restored. My RadioBoatAnchor blog covered the restoration of my dad's receiver in 2015. This Mohican receiver restoration project was just as gratifying as the first, as it was truly a basket case. Please like this post and subscribe to RadioBoatAnchor so that you're alerted of my future posts. Thank you.